Welcome to Sundar's lecture. This is lecture number 70, and in this lecture we are going to see some numerical problems. It is simple numerical problems related to RLC circuit in transient network, right? So what are the topics we have seen in the previous class? These are all the topics we have seen in the previous class, transient responses of LC circuit, and we have found that there will be some energy stored in the circuit forever. And see, before that, in lecture number 68, we have seen this one, right? Numerical examples. Two problems we have seen. See, in this lecture, we have taken some problems, complicated problems. But now, because students request me to solve some simple problems so that they will get a idea about RLC network, that means in transients. So, I have taken this lecture with the simple problems, right? So now you see a series RL circuit with the resistance R is equal to 50 ohms and L is equal to, that means inductance is 30 Henry as constant voltage of 50 volt applied at t is equal to 0 as shown in the figure. Find I of t and V of t, and then we need to draw the graph. See what is the value of V. V is 50 volt, it is given 50 volt, and what is the value of R? R is 50 ohms, R is 50 ohms, and L they have given 30 Henry, right? 30 Henry. So these are the data they have given you, and they are asking you to find what is the I of t and V of t value. See, they have not given you what happens before closing this switch, right? So you try to assume that the inductor carries zero current before closing the switch. So obviously the thing you have to write it as I of 0 will be is equal to 0 amperes. That you have to understand it clearly. That is the initial condition. Initially, if they have given you initial condition, then you take it. Then you take that as a current value. Some current value they would have given you before closing the switch. The inductor carries 1 ampere or 2 ampere. That is those kind of things they will give you. They have not given you, then you take that as the zero condition. So, sorry, 0 ampere and as an initial condition, right? So this is the initial condition. Now you see, after closing the switch, I have told you already all these kind of things. So what happens before closing the switch? You take that as the initial condition, and if the switch is closed, then after S closed, then you have to find the value of current and voltage. This is the procedure we have followed in the lecture number 16, right? Now you see, if this switch is closed, now the circuit will be RL circuit, right? So what you can do now? So what is the I of t? You know, I of t will be is equal to E by R plus A e power minus L by, sorry, R by L t. This is the equation we have seen in the derivations, and now you see what is the value of A. You need to find it out. First, what you do, you just try to substitute all the values. What is E here? Which means it is E here. So this is the 50 divided by resistance value is 50 plus A e power R by L. What will be the R by L? It is 50 divided by 30. So it will be 1. It will be maybe I will put it down. It is 50 divided by 30. Maybe it will come as 1.167. So this is the equation. Now I can write it as I of t can be written as 1 plus A e power minus, I am getting 1.67. So this is the equation, and now you can apply the initial condition. What do you know? I of 0 will be 0, right? I of 0 will be 0, and you substitute I of 0 here in this expression. You will get 1 plus A e power 0, it will be 1, right? So this has to be equal to 0, right? So this is the expression, and A can be written as minus 1. A can be written as minus 1. And what is the final expression of I of t? So I of t can be written as 1. This A is minus 1 e power minus 1.67 t, and if you further simplify this, you get 1 into 1 minus e power minus 1.67 t, and this is the expression. You know these kind of things. And now if you want to find what is the value of V of t, what is the expression? What is the voltage across the inductor formula? It will be L di by dt. That you know already, right? Now you just substitute this on this expression here. What you will get? So this will be is equal to, what is the value of L? It is 30. 30 multiplication of this d, maybe I will put it as d by dt of, what is the value of I? It is 1 minus e power minus 1.67 t. I can write like this, and if you simplify this, what you will get? So if you differentiate 1, it will be 0, and if you differentiate this one, this one will 1.61 will come down, and it makes it to plus 1.67 e power minus 1.67 t, right? This is the expression, and if you further simplify this, you will get V of t will be is equal to 50 e power minus 1.67 t. So this is the V of t expression. Make it as expression number 2, and this is the expression number 1, or maybe you take it as 1, or any one, right? So this is the I of t and the V of t expression, and it is now very simple. It is not a very big thing to understand. See, I will draw the graph here itself, because these kind of things are all very simple, right? Why I am saying this? See, if I am going to draw the diagram, let me take this as the x-axis, this is x-axis, this is y-axis, and if I take this as the t, and if I take this as I, see, it is 1 minus 1 e power minus 1.67, right? E by r minus e by r e power minus r by lt is the expression, and I have told you already, if something is if the expression of I of t is coming like 1 minus e power minus 1.67, then that curve will be increasing exponentially, and it will be down to this value. That is the thing you have to understand, right? Because if you draw the diagram, see, if this is the 1 ampere, if this is the 1 ampere, then what happens to the curve? It will be increasing, maybe this is the 1 ampere timing, and this curve will be increasing, and it will be down to 1 ampere after some time. And this curve, which is nothing but it is I of t, which is equal to 1 minus e power minus 1.67 t. So this is the curve for current, and for voltage, so this is the x-axis and this is the y-axis, and if I take this is t and this is v, and you see what is the value? It is decaying curve, right? Because there is no 1 minus value here, 1 minus e power values here, so it will be decaying curve. What happens here? If, for example, this is the 50 volt, this is the 50 volt, and what happens to the curve here? This curve will be decaying down to 0. Will be decaying down to 0. You put t is equal to, you put in this expression t is equal to 0 and t is equal to infinity. You will get, for t is equal to 0, obviously you will get 1 amperes, and for t is equal to infinite, sorry, t is equal to 0, you will get 0. It will be 1, and for this expression, for t is equal to 0, you will get 50 volt, and for t is equal to infinity, you will get 0 volt. So that is the curve. So you already, we have seen these kind of graphs, but with some numerical examples, it will be very easy to understand, right? So now we will take another problem, and now you see we have taken the second problem, In circuit as shown in the figure, switch was connected to position 1 for sufficient time and at steady state. See, this switch is connected to position number 1 and with 50 volt, this circuit is connected for some sufficient period of time and we are assuming that it is at steady state. Not assuming, maybe it was given in the question itself. See, the next point, the switch is moved to position number 2 at time t is equal to 0. Then you need to find what is the transient current I of t. That is the given question. See here, maybe switch at position number 1, that is the first case. At position, switch at position 1 is the first case. And what happens here? If switch at position 1 and it has been said that it is at sufficient period of time and at a steady state. At a steady state, what happens? What is the current flowing through this inductor? It will be E by R. It will be E by R, right? We have seen these kind of things, right? If it is connected to this switch, is connected to this voltage and it has left to the sufficient period of time, then the current will be E by R. That is what we have seen it as I infinity will be E by R in the RL circuit, right? So we can write it as I of, maybe I will take that as I of 0 because I am going to, the switch is going to connect at position number 2, right? So it will be E by I of 0 and it will be E by R. And what is this value now? It is 50 divided by 40, right? So if I simplify this, I will get 1.25 amperes. So now for the second case, switch at position 2. Now it is connected to position 2 and now I need to find what is the current value. It is very simple, right? What is the current now? If it is RL circuit, then I of t will be is equal to E by R, maybe 1 minus E power minus, sorry, E by R plus A E power minus R divided by L into T. This is the expression, right? This is the expression. And if you substitute all the values, what you will get? What is E here? If it is connected to position number 2, it will be 10 divided by what is the R value? It is 40. So it is 1 by 4 plus A E power R by L, right? So it will be 40 divided by minus 40 divided by 20 into 10 to the power minus 3 into T. So if I further simplify this, I will get, so I of t will be is equal to 0.25 plus A e power minus 2000 T. So this is the expression. And I need to find what is the value of A, and we know that the initial condition I of 0 is 1.25. So I of 0 will be is equal to 0.25, maybe I will put like this, 0.25 plus A e power, see if I put 0, it will be minus 0 and that should be is equal to 1.25. And if I further simplify this, this will be A, this value will become 1, this 1.25 will go other side. So A value will be 1. A value will be. And what is the final expression of I of t? So I of t will be is equal to this value, it is 0.25 minus 1, and I don't need to put this 1. So it will be e power minus 2000. So this is the I of t expression, and you put amperes. So this is the value of I of t. See, these kind of problems are very simple to understand, and you know this expression. You should know this expression, and you try to get this expression, because we have seen in the derivation itself these kind of expressions. You don't need to panic when the circuit as given as RL circuits. So you try to understand these kind of problems, right? We will take another problem. And now you see, we have taken the problem. in the RL circuit shown in the figure, the switch is kept at position number 1. It is kept at position number 1. After t is equal to 100 milliseconds, the switch is changed to position number 2. Find the transient current I of t. See, you try to understand this one very clearly. At position number 1, it is not left for sufficient time so that the circuit will be at steady state. See, it is connected to position number 1 at some time and it has left 100 milliseconds and then it is changed to position number 2. It is very important to understand. So let me write it down. So switch at position 1, and that should be the initial condition. So we know this one, right? So I of 0 we need to find it out here. And you see it is not connected forever, right? For maybe not forever, it was not given sufficient time so that the circuit becomes steady state. And now, so that what we need to do, we need to find what is the I of t here. And then we will make that value as t is equal to 100 we put t is equal to 100 milliseconds and then we will make it to the initial condition. See, I of t should be is equal to E by R, we know this one, E by R plus A e power minus R L by T. So this is the this is the expression. And what is E by R here? What is E here? It is 5. At switches at position 1 means it is 5 divided by what is the value of R, it is 2 here, plus A e power R by L, we need to put R by L. What is R by L? It is R divided by L. So it will be 2 divided by 0.2 and T. So what is the expression you will get? It is 2.5 plus A e power, maybe put minus here, minus 10T. It will be the expression. And now you see we need to find what is the initial condition. For this case, you need to know what is the initial condition. They have not given you anything here. So what you do, you put 0, I have 0 for this condition, maybe for this condition, to get the value of this condition, it is 0. Well, see, what is this I of 0 and this I of 0, you make a difference between these two, because at case number 1, we should know what is the initially what is the current flown through this inductor, and that was not given here, so I am taking it to 0, right? So if you want to make a difference, I put star here. So if I put star, then I of 0, then I of 0 star will be is equal to 2.5 plus, and then this A is there, and it is given as A, and it becomes now 1, and this would be is equal to 0. And what is the value of A now? It is minus 2.5. And if I put I of t now, that should be is equal to 2.5 minus 2.5 e power minus 10t, right? This is the expression. And you see this switch is closed after 100 milliseconds. And then what I need to do, I need to get what is the 100 milliseconds. See, I have to substitute what is t is equal to 100 milliseconds. So it is 2.5 minus 2.5 e power minus 10 into 10 100 into 10 power minus 3. And if I simplify this one, I am getting it as 1.5803 amperes, right? This is nothing but I of 0. This is nothing but I of 0. So this value will be I of 100 milliseconds. And we have found what is the initial condition for position number 2 now. So now if this switch is connected to position number 2, then what happens? We need to find the expression. See, the switch is connected to position number 2 now. Now you see in this circuit, the current will flow in this direction, right? See, at first, the current direction, I need to mark it down. See, first position number 1, the circuit is connected like this. The voltage is plus here, minus here. So this current will be like this. This is I of 0 would have flown in this direction. That is what I have marked here. Now if this switch is connected to position number 2, now what is the direction of current? The direction of current will be like this. It is I of t. I'm just writing it as I of t. See, this both are in the opposite direction. So for that, what I am doing here, I of 0, I will make I of 0 should be is equal to minus 1.5805. 5803 amperes. I am just taking it to be minus because the current, both current are in opposite direction. Right? You don't need to do so many complications to get this value of I of t. Try to understand me. I have just changed this current direction. And now what we can do, what is the if switches at position number 2, then this circuit will be connected like this, and I can write I of t can be written as, what is this one, e by r plus a e power minus r by lt. That's all, very simple. What is e here? It is 20 divided by, what is r here? It is 2 plus a e power r by l, it is same, right? It is 2 divided by 0, 2 divided by 0 0.2, it will be minus 10t. So if I further simplify this, I will get 10 plus a e power minus 10t. That is I of t. So what is the I of 0 value here? It is 10 plus a. If you put 0 here, it will be 1. That should be is equal to minus 1.5803. And if I further simplify this, a will be is equal to minus 11.5803 amperes. And if I substitute this one in this expression, what I will get, it will be I of t, sorry, in this expression, I of t will be is equal to 10 minus 11.5803 e power minus 10t. This is the final expression. See, these kind of problems are very simple, but if you see the problem, it makes you to think that it is very complicated. No, not like that. You try to find, that is what I have told you from the beginning. While solving the problem, you just understand the problem by two cases. What happens when the switch is connected to one position of position number 1, and what happens to the circuit when it is connected to the another position. And if you know how to solve the problems at particular positions, then it is very simple to understand, right? That is how you need to solve the transient responses problem. You try to solve many more problems by your own. I have taken very simple problems in this lecture because students requested me to solve some simple problems, because that will help them to solve the problems in their examinations. So I have just solved the problems in lecture number 68. That is little bit complicated problems, right? You can see these kind of problems in GATE exams or in NPTEL exams. But these kind of problems are very simple and it will be asked in the questions, maybe your examinations, right? You try to solve many problems by your own. That will help you to understand the RL, RC circuits with DC inputs, right? So in the next class, we try to take the transient responses of RLC circuit with AC excitations. That will be very interesting because with AC excitations, you can uh, get what is the DC component in the AC circuit and also what is the steady state component, and we will have the steady state component that should be connected, sorry, that should be taken as the final expression, and those kind of things we will see in the next class. That will help you, right? Thank you.